I did an undergraduate degree in maths and physics at Bath, and then after that I did a master's in data assimilation, and then moved on to a PhD at the University of Reading, looking at 3D cloud retrieval algorithms using cloud radar and LiDAR. And that's really what got me into working with EarthCARE. So later on in 2016, I joined ECMWF, working on the ESA EarthCARE project. ECMWF, or the European Centre for Medium Range Weather Forecasts, is involved in several ways with EarthCARE. So one of these, and that's something that I'm involved in, is we're going to be involved in the calibration and validation activities of EarthCARE. So we'll be monitoring the satellite observations of cloud radar reflectivity and LiDAR backscatter, and using our model to check that the observations are how they should be. Another thing is that we're going to be assimilating the data, so that means we're ingesting them into our weather forecasts to hopefully improve our forecasts of cloud and precipitation. And also scientists at ECMWF have been involved in developing the synergistic retrieval algorithms that's combining all of the observations that Earth is going to give us into information about clouds, precipitations, and aerosols. My professional contribution to EarthCARE is I've been developing the forward models, so that's how we've been simulating the radar and LiDAR observations from within our model. So it's a bit like having a mini satellite running within the weather forecast. It simulates what the satellite would see, and we compare that to the actual satellite observations to help monitor or assimilate the data. Having 4 different observation types from EarthCARE is really a unique and brilliant sort of powerful tool that we're going to be able to use to help improve our weather forecasts. So in particular, it helps sort of really see into the depths of clouds and being able to understand not just at the cloud tops, which is what a lot of current satellites see, but delving further into the clouds and being able to retrieve information with a lot greater accuracy. I see it as a symbiotic kind of relationship in the sense that ECMWF will at first help to monitor EarthCARE's observations. So we're going to be checking, validating them, also sort of sanity checking the calibration, making sure they're looking as how we expect. And then once we do that, then we move on to the second stage, which will be assimilating the data. And that's ingesting them into our forecast system, which will help improve the initial conditions of the atmosphere, and then we'll run our forecasts. EarthCARE observations are going to help improve models in a variety of ways. So in addition to improving them through the data assimilation, we also have the indirect impact of learning about the physics that's going inside clouds and improving our parameterizations of clouds and precipitation processes. So I'm particularly excited about the Doppler velocity observations that EarthCARE is going to tell us. So it's going to tell us how fast snow is falling, how fast rain and drizzle drops are falling, and in a global sense. So this is something we've not had before at all from any observing system. So it's a really novel aspect of EarthCARE, and it's going to really help sort of improve our forecasts. And we just, at ECMWF, we can't wait for EarthCARE to get up there and start receiving the data from it. At ECMWF, we're part of the integrated commissioning team for the radar and for the LiDAR. So we'll be getting the data as soon as like the instruments are ready to start sending the information back to Earth. But it will be a few months, maybe 6 months to a year before we'll be able to start really assimilating the data, because it takes a while to make sure that the observations interact with the other observations in the observing system. Really looking forward to the high spectral resolution LiDAR that's aboard EarthCARE. And I think this is a really unique instrument, and it will be giving us both cloud information but also aerosol information. And this is really one of the big uncertainties, both in numerical weather prediction, but also particularly for climate change. So understanding how aerosols and clouds interact better will be something that's a real bonus coming from EarthCARE.